the previous video we discussed about the two type of enthalpies. Third type I'm going to discuss. So that is the standard heat of combustion. So I can write here that del H, which is the change in heat, and C, which is the combustion, and not with the standard condition. So it can be only negative, which is exothermic reaction, because of the combustion is exothermic reaction, and the condition of the reaction is that the reactant must be the 1 mole. Alright, for example, I'm having the propane plus 5 oxygen. So there is what so this will basically does not involve, so we will see this here. You can see that here it is 1 propane, 1 mole, it is 1 mole. Alright, and the heat that is released will be the negative because of the exothermic reaction. Second, you can take the example C2H6 plus 7 oxygen. This will not involve because of the combustion, and there is a 1 mole, and the product will be the 2 carbon dioxide plus 3 H2O. So this is also a exothermic reaction, 7/2 because of the oxygen. Alright, so this was about the standard heat of combustion. Next I'm going to discuss that is basically the standard enthalpy of neutralization. Alright, so this is basically, I can write here that del H is equal to the N naught. Alright, so here the condition, if I talk about, that is the product must be equal to the 1 mole of H2O. The product should be the 1 mole of H2O. For example, I'm taking here the neutralization reaction HCl plus base, and here there is the Na plus Cl. Alright, so here it is also the formation of the water, for example. So you can see that in the reactant there is there is a 1 mole of the water. Alright, this is the ion in the ionized form. So this is the standard heat of neutralization. Alright, so if I talk about that, for example, fifth one type of enthalpy, there is the enthalpy of a solution. So I can write here del H is equal to the solution and the not. Alright, so here the condition is that the product must be ionized. Or which means the aqueous form. It can be both negative as well as the positive. This I haven't tell you, I am telling you just after this. So for example, I'm on the reaction NaCl plus H2O, and there is the formation of the Na plus NCl. There is the formation of the aqueous sign. So this is the ionized sign. This can be the example, and it is a negative reaction because of the heat is released in this reaction. Second, I am going to discuss, for example, NaCl, and you can take any solvent. The solvent can be alcohol, benzene, sulfuric acid, and there is the formation of the Na plus Cl. So it is also in the this is also the in the aqueous form, and it is a del H is equal to the negative. Alright, you can take the example the ammonium chloride in the form of water. So you will get the ammonium and chloride. These are the ionized form aqueous form molecules. So that is also the enthalpy of solution. Last reaction, there is the enthalpy of atomization. Alright, so here it is the del H is equal to the 80, and that is always positive. So the product, if I talk about that, is basically should be in a gaseous atom. How? Let's see. For example, I'm having this one hydrogen in the molecule form, in the diatom form. Sorry. So here it is what it is. I'm giving the 5,000 heat, and here it basically change into the gaseous product. Alright, this is in the gaseous product. So it is what is the gaseous atom. This is the gaseous atom. So this is what this is the here it was in the atom fall. It was in the diatomic, and it was a atomization. It means the to break the diatom into the atom. So the heat that is given to that to break this, so that is called the heat of atomization. All right. So this was about the this. So one thing I want to tell you guys, the product and reactant must be in the equal state if it's a physical reaction. So this was about the four remaining reactions, and two I have discussed in the previous video.